Hello everyone, myself Pansar Srinivas. I am from CSIT B section. My roll number is 33C7. My topic is about climate change impacts on rainfield and maize yields in Zambia under conventional and optimized crop management. Here we discuss the climate changes and conventional and optimized crop management systems for yields. And to the introduction to the climate change and agriculture in Zambia. Climate change poses significant challenges to agriculture in Zambia, particularly affecting the rain-filled maize production. Maize is a staple crop vital for food security and income for majority of Zambian farmers. Understanding how climate change impacts maize yields under different management practices is essential for developing resilient strategies. Importance of maize in Zambia economy and food security. Maize accounts for a large portion of Zambia's cultivated land and caloric intake. Rain-fed maize production is highly vulnerable to weather variables and climate functionalities. Ensuring stable maize yields is critical for national food security and economic stability. Climate change trends in Zambia. Zambia has experienced increasing temperatures and changing rainfall patterns over recent decades. These climate shifts may lead to more frequent droughts and irregular rainfall distributions. Such trends threaten the traditional rain-fielded agriculture systems prevalent in the country, which causes a food scarcity in the present situation in Zambia. Conventional crop management in Zambia. Conventional management involves traditional practices with minimal inventions or intervention or adaptation. These practices often rely on local knowledge with limited use of inputs or technologies. Under climate stress, conventional methods may not optimize yields or resources use efficiency. Optimizer crop management strategies. Optimizer management incorporated improved practices, technologies, and resources to enhance the resilience. Techniques include improved seed varieties, precise fertilizers application, and water conservation methods. The goal is to increase the productivity and reduce the vulnerability to climate variability. Climate change impacts on rainfield and maize yields, like conventional methods. Climate change has led to variable rainfall, reducing the reliability of rainfed and maize yields. Increased temperatures can cause heat stress, impacting the crop growth and development. Drought events under conventional management often result in insufficient or insignificant yield reductions. Climate change impacts on rain-filled maize yields. Optimized management. Optimized practices can mitigate some climate impacts by improving water use efficiency. Use of drought-tolerant maize varieties helps the maintain yields under stress conditions. Enhanced management can buffer the effects of climate vulnerability and stabilizing the production. Cooperative analysis of yield responses. Studies show that optimized management generally results in higher and more stable maize yields. Conventional systems tend to experience greater fluctuations and lower average yields under climate stress. The difference underscores the importance of adopting improving practices for resilience. For further resources, we can manage through the yield productions and analyze the results to produce enough results. Role of climate smart agriculture in Zambia. Climate smart agriculture integrates adaptation, mitigation, and productivity goals. It encourages the practices that improves resilience, reduce greenhouse gas emissions. Adaptation of climate smart technologies is critical for sustainable and maize production in Zambia. They have to use climate smart technologies, and we have to reduce the greenhouse gases to produce a more yield towards the interactions. Water management techniques for rainfield and maize. Rainwater harvestment and conservation tillage improves water availability during dry spells. Efficient irrigation methods are often unfeasible in rain-fed systems, emphasizing soil moisture conservation. These techniques are vital for maintaining yields under changing rainfall patterns across different mechanisms. Use of drought tolerant maize varieties. Drought tolerant varieties are bred to withstand water stress and maintain productivity. Their adaptation has shown promising results in reducing yield losses during dry conditions. Promoting seed diversity and access is key to the widespread use among farmers, along with a different sort of techniques. Role of fertilization and soil management. Proper fertilizers application enhances the soil fertility and crop resilience against climate stress. Conservation tillage helps the retain soil moisture and reduce the erosion risks when there is some droughts or any other thing. NPK values like nitrogen, potassium, and phosphorus is essential for soil growth and plant growth. These practices contribute to improve maize yields under both conventional and optimized management. Policies and institutional support for climate resilience. Effective policies are needed to promote adaptation of resilient practices among farmers. Extension services and training play a crucial role in disseminating improved management techniques. Investing in research and infrastructure supports sustainable maize production amidst climate change. Challenges to adaptation of optimizer practice. High costs and limited access to inputs hinder widespread adaptation of improved techniques. Lack of awareness and knowledge gaps can slow down the transition from conventional methods. Addressing these barriers requires targeted policies and funding and capacity building initiatives. Implications for food security and rural livelihoods. Resilient maize production systems are essential for securing food and income for smallholder farmers. Climate change may exacerbate rural poverty if adaptive measures are not implemented. Scaling up optimized practices can foster sustainable development and resilience towards the scarcity. Recommendations for enhancing resilience. Promote the adaptation of drought tolerance maize varieties and water conservation techniques. Strengthen extension service to educate the farmers on climate smart practices. Support policies that subsidies inputs and facilitate access to innovative technologies. throughout the country to enhance the productivity. Further research and innovation needs Further studies are needed to evaluate long-term impacts of climate change on maize yields. Development of local adapted climate resilient maize varieties remains as a priority. Innovative approach should integrate socio-economic factors to ensure the practical adaptations. Conclusion: building a climate resilient maize systems in Zambia. Climate change poses serious threats to rainfield and maize yields, especially under conventional management. Optimizer practice can significantly improve the resilience and stabilize production. A combined effort involving policies, technologies, and farmer engagement is essential for sustainable outcomes. Key takeaways: climate change impacts required a proactive adaptation strategies to protect the maize yields. Adaptation of improved management practices enhances the resilience and food security. Collaboration and among stakeholders is vital for transforming agriculture in Zambia. Thank you for giving this opportunity to informate about Zambia's maize fields during the essential conditions.